Did you know that by 2026, the global AI market is projected to grow to a staggering $554.3 billion, a significant leap from $62.35 billion in 2020? Our world has witnessed an exciting evolution in technology, with artificial intelligence leading the charge. This revolutionary force has permeated numerous sectors, reshaping traditional methods and ushering in an era of increased efficiency and simplified processes. One of the most groundbreaking developments in this space is the rise of conversational AI. This technology seeks to enhance the interaction between humans and digital systems, making our digital companions more relatable, more human. And standing at the forefront of this technological revolution is ChatGPT. ChatGPT, an AI-powered chatbot, has become a beacon of conversational AI. It's not just a chatbot, it's a robust framework that allows users to tap into the potential of conversational AI, blurring the lines between human and machine interaction. The evolution of AI technologies such as conversational and generative AI has made ChatGPT a point of interest for tech enthusiasts, commercial entities, and the general public. It offers immediate access to a wealth of information, serves as a multifunctional assistant for everyday tasks, and even acts as a reliable virtual companion for users. But that's not all. ChatGPT's sophisticated programming abilities have garnered global attention. With its powerful coding skills and flexible functionality, developers can streamline their workflows, save precious time, and create innovative software with unprecedented ease. It's no secret that creating software can be a complex and labor-intensive task. With ChatGPT, developers can bypass the intricacies and focus on what truly matters: innovation and enriching user experiences. In the upcoming series, we will delve into the intricacies of this powerful AI-driven chatbot and explore the process of developing an application utilizing its capabilities. Artificial intelligence, AI, has emerged as a pivotal force in driving progress and streamlining operations across numerous sectors. It has given rise to software solutions that serve a multitude of functions, achieving tasks that traditionally required human intervention, thereby enhancing efficiency and simplifying processes. Among the most groundbreaking strides in AI is the advent of conversational AI, which aims to refine the interaction between humans and digital systems. ChatGPT, a chatbot powered by AI, has become widely recognized and stands as a prime example of conversational AI. It offers a robust framework that empowers users to leverage the capabilities of conversational AI, diminishing the distinction between human and machine interactions. With the ongoing evolution of AI technologies like conversational and generative AI, ChatGPT has sparked interest among tech experts, commercial entities, and the broader community. It delivers a host of advantages, such as immediate access to extensive information, multifaceted support for everyday activities, and a reliable virtual companion for users. As it continues to evolve and become more accessible, ChatGPT is solidifying its role as an essential asset in today's digital era. Notably, it's ChatGPT's sophisticated programming abilities that have garnered global attention. Utilizing its potent coding skills and flexible functionality, developers can optimize their work processes, conserve time, and forge groundbreaking software with exceptional ease. ChatGPT's guidance simplifies the intricate and labor-intensive elements of software creation, enabling developers to concentrate on innovation and the enrichment of user experiences. In this comprehensive two-part series, we will delve into the intricacies of this potent AI-driven chatbot and explore the process of developing an application utilizing its capabilities. Exploring ChatGPT, a primer. ChatGPT is a cutting-edge artificial intelligence language model crafted by OpenAI. At its core, it's anchored in the technology of large language models, LLMs, which are advanced machine learning models with the capability to understand and produce human-like text. Generative. This aspect refers to the model's ability to generate original content that is contextually relevant, closely resembling the flow and substance of human dialogue. Pre-trained. ChatGPT has been pre-trained on a vast corpus of text from various sources, allowing it to recognize complex language patterns, contexts, and facts. This extensive training forms the groundwork for its sophisticated text generation abilities. Transformer. The transformer architecture is the foundation upon which GPT models are built. Utilizing self-attention mechanisms and parallel processing, these models efficiently handle large-scale language tasks and produce text with remarkable contextual precision. The origins of ChatGPT can be traced to 2018 with the debut of OpenAI's original GPT language model, which set the stage for ChatGPT's creation by mimicking human-like responses. The journey began with GPT-1, an initial yet promising model. The following year, GPT-2 was introduced, marking a considerable advancement in the model's ability to understand and generate language. The true transformation occurred with the introduction of GPT-3 in 2020, which revolutionized the field of generative AI with its unparalleled abilities. Building on this success, GPT-3 was refined into GPT 3.5, an enhanced version that became widely accessible through OpenAI's platform. In November 2022, ChatGPT was officially released by OpenAI and quickly rose to fame. Capitalizing on the achievements of GPT 3.5, OpenAI then released GPT-4, further improving ChatGPT in terms of performance, scalability, and functionality. ChatGPT harnesses the power of AI to understand and generate text, responding adeptly to user inputs. Its range of uses is broad, encompassing query resolution, content generation, and language translation, among others. To refine these models, OpenAI has engaged human AI trainers who use reinforcement learning coupled with human feedback to enhance the user experience. As a result, ChatGPT offers accurate, prompt, and context-sensitive answers to a wide array of user inquiries. With its advanced capabilities in text generation, ChatGPT is applied in various sectors and business scenarios, including customer support, content development, and coding assistance. It exemplifies the revolutionary impact of AI in transforming everyday life and workspaces. The rapid progression of ChatGPT, evolving from its GPT-3 origins to the more sophisticated GPT 3.5 and the latest GPT-4, mirrors the swift advancements in the field of generative AI research and innovation. Understanding the functionality of ChatGPT belongs to a sophisticated class of machine learning models within natural language processing, NLP, called large language models, LLMs. LLMs analyze extensive amounts of text data to understand the relationships between words. The capabilities of these models have significantly advanced alongside improvements in computational power. The performance of LLMs improves as their training data sets grow larger and their parameters become more extensive. Although GPT-3, the underlying model of ChatGPT, has achieved significant progress in natural language processing, it sometimes struggles to perfectly match user intentions. For example, GPT-3 could produce responses that, while GPT-3, the core model behind ChatGPT, has made notable advancements in natural language processing, it occasionally does not fully align with user expectations. For instance, GPT-3 might generate responses that are not useful or do not comply with the user's direct instructions, create hallucinations, or make claims about things that are untrue or do not exist. Produce outputs that are difficult for humans to understand, obscuring the rationale behind the model's decisions or predictions. Produce content that is toxic or biased, which can lead to the spread of harmful or offensive material and misinformation. Semantic mapping's vector embeddings are fundamental in aiding ChatGPT to discern and produce responses that are pertinent to the context. Utilized during the pre-training stage, these embeddings are numerical representations that encapsulate the meaning and grammatical connections between words, phrases, or sentences. This allows the model to interpret and create language that closely resembles human communication. In its pre-training stage, ChatGPT acquires vector embeddings by analyzing a large collection of textual data. It assimilates the contextual nuances and the interrelations among words, phrases, and sentences within a multidimensional space. These vector embeddings are instrumental for ChatGPT to grasp the significance, subtleties, and interdependencies of the input data. Upon receiving a user's prompt, ChatGPT employs these pre-learned embeddings to decode the context and word relationships within the prompt. Subsequently, it crafts a response that is contextually appropriate by selecting embeddings that align closely with the input's semantic and syntactic properties. Vector embeddings are key to ChatGPT's ability to produce responses that are both coherent and relevant to the given context. They also facilitate the model's capacity to apply its learned knowledge to novel inputs. This capability stems from the embeddings function of encapsulating the foundational structure and linguistic patterns, which empowers the model to tailor its responses to diverse prompts. Through this process, the model attains a broad-based comprehension of language. Refinement process ChatGPT evolves from InstructGPT, which introduced a novel approach of incorporating human feedback into its training process to align the model's responses more closely with user intentions. This method, termed reinforcement learning from human feedback, or RLHF, is thoroughly described in OpenAI's 2022 paper titled Training Language Models to Follow Instructions with Human Feedback. Below is a straightforward rundown of that methodology. After the initial pre-training, the fine-tuning stage begins. During this phase, ChatGPT undergoes additional training with a specialized dataset that's been selectively compiled to suit specific tasks or domains. This dataset is composed of input-output examples crafted by human trainers who construct model responses that align with a set of given prompts. During the fine-tuning phase, ChatGPT's parameters are refined to more closely match the requirements of the intended task or domain. This step enhances the model's ability to produce responses that are precise, pertinent, and beneficial for the particular situation or challenge being addressed. The fine-tuning process tailors ChatGPT's broad linguistic abilities developed during pre-training to meet the unique needs of a specific task. In the fine-tuning stage, methods like reinforcement learning from human feedback, RLHF, are employed to reduce the likelihood of generating outputs that are detrimental, misleading, or prejudiced. This approach includes a mix of supervised fine-tuning, reward modeling, and proximal policy optimization, PPO. The goal of RLHF is to refine the model's responses to reflect human preferences, guaranteeing that the generated text is precise, approachable, and consistent with the expected results. The GPT-3 model undergoes a multi-stage refinement process. Here is an in-depth look at each step. The first step in crafting ChatGPT involved the supervised fine-tuning, SFT, of the foundational GPT-3 model. A dedicated team of contractors compiled a training dataset with specific inputs and their corresponding outputs. These prompts were derived from actual user inquiries submitted via the OpenAI API, and the contractors developed appropriate replies, resulting in a dataset with clear input-output pairings. This dataset was then used to fine-tune GPT-3, leading to the creation of the SFT model, also known as GPT 3.5. To ensure a wide variety of prompts, a limit of 200 prompts per user ID was set, and prompts with long similar beginnings were excluded. Additionally, any prompts containing personally identifiable information, PII, were removed to protect privacy. The contractors also created sample prompts to fill in gaps in areas where real data was insufficient. These included plain prompts, basic inquiries lacking specific context, few-shot prompts, instructions that include several examples of a query, followed by a request for another. User-based prompts, specific scenarios requested via the OpenAI API. The contractors aim to interpret the user's intended command when crafting responses. According to the paper detailing this process, prompts typically seek information in one of three ways. Direct, straightforward requests for information, such as, "Tell me about." Few-shot, prompts that offer a couple of examples on a subject and then ask for an additional one. Continuation, prompts that begin a narrative and invite the model to continue it. Combining the prompts from the OpenAI API with those generated by the contractors resulted in a dataset of 13,000 input-output pairs, laying a strong groundwork for the supervised model. The subsequent phase in refining ChatGPT involves the creation of a reward model, which follows the initial supervised fine-tuning. This model evaluates a set of prompts and their corresponding responses, assigning a numerical reward to each. The reward model is crucial for implementing reinforcement learning, as it guides the model to produce responses that yield higher rewards, which will be further explained in the next step. During the training of the reward model, labelers are presented with multiple responses generated by the SFT model for a single prompt. Their role is to rank these responses from highest to lowest quality, creating various ranked sets. Initially, treating each ranked set as an individual data point led to overfitting, where the model performs well on seen data but poorly on unseen data. To overcome this, the training process was adjusted so that each set of rankings is considered a single batch of data. This modification helps the model to generalize its learning more effectively and prevents overfitting. The third step is the application of a reinforcement learning (RL) model. At this stage, the model undergoes further refinement through reinforcement learning techniques. It receives a random prompt and generates a response based on a strategy or policy that was developed during the supervised fine-tuning phase. This policy is designed to optimize the model's performance by maximizing rewards. The reward model, established in the previous phase, evaluates the prompt-response pair and assigns a numerical reward. This evaluation informs the RL model on how to adjust its policy for better outcomes. While it's possible to iterate over the second and third steps to enhance the model's performance, this iterative process has not been widely adopted in real-world applications.